This experiment is of about the half wave rectifiers and full wave rectifiers using op-amp. So in your first year you have been discussed your construction of half wave and full wave rectifiers using diodes. Now the same circuit we are going to implement it with the help of op-amps. So first we will discuss about the half wave rectifier. In the next video we will discuss about the full wave rectifiers. So this is a circuit diagram of a half wave rectifier, and as you see here you can see an input AC voltage is coming inside to the inverting terminal of your op amp, and your non-inverting terminal has been grounded, and for time being we are using IC741 op amp, and you can see a diode here IN1N4001 as the diode, and one feedback resistor of 10k is given, and we have connected a load of 1k at your output. So we have two diodes at these places, and we are going to see how the rectification is going to take place. So as you see here that this black IC indicates your IC741, and these two are your diodes, and these are the supporting resistors, I mean your feedback resistor and your input resistor and your output load resistors. And you can see that we are going to use a normal dual DC regulated supply, and you know the reason why, because for 741 IC we need to give plus and minus biasing for the pins 4th and 7th pin. So, and again we are going to use the DSO for taking the results, and we are going to give the function generator for as the sinusoidal input to our circuit, right, half wave rectifier circuit. So here I have set it as a sinusoidal waveform, and you can see here I have chosen a sinusoidal waveform, and I have kept a frequency of 955 Hz, which is approximately equal to 1 kilohertz, and we are going to check the result, how the rectification going to take place. So now I have set the output. We are going to measure how the output is going to be present here. So if you check this channel 2, which is in blue color, this is your input sinusoidal waveform, and the yellow color waveform is your output, that is a half wave rectified output. You can see the positive half cycle, negative half cycle inversions because of your inverting inputs, and you can measure the values with the help of the measure option present in your DSO. So we can measure here, you can see 957.9 Hertz, which is approximately equal to 960 Hertz at your input. So what we measured is what we received. Similarly, we can also measure the time period. So the time period is around 1 milliseconds, and the mean value of the voltage signal and the peak to peak value is around 8.6 volt. And the RMS value is around 4 volt, and the other type of measurements, minimum voltage is also have been given, the maximum voltage is also have been given. So like this you can also measure for channel 2. You can measure for channel 2, you can see the measurements here. So these are the measurements. So first the frequency is 956, so for channel 2 also the same frequency is maintained, and again the same time period is measured. So this is about the half wave rectifier. Thank you.